Our goal in this worksheet is to find the value of each of the trig ratios indicated. In this first problem, we'll get started doing that by finding the value of the hypotenuse C here. We need to find the value of C so that we can use it to find some of the other trig ratios. So to do that, we'll use the Pythagorean theorem. We have 6 squared plus 8 squared equals C squared, and we end up getting C equals 10. We can replace this C now with a 10 and use that to find the value of some of our trig ratios. Move this work out of the way here. Now, before we go any further, we need to know what the sine and cosine and tangent of an angle means. Remember, when we do these trig ratios, we need to have a reference angle with them. So if we have the sine of a reference angle, that's going to equal the opposite leg over the hypotenuse. The cosine of a reference angle is adjacent leg over the hypotenuse, and the tangent of the reference angle is the opposite leg over the adjacent leg. So I'll put these formulas up here so we have reference to them later. And let's go ahead and get started now with the sine of A. Since we are finding the value of a trig ratio for A is going to be our reference angle here. So A is our reference angle. Sine is opposite over hypotenuse, so opposite angle A is 6, and the hypotenuse is 10, so we get 6 over 10. And then, of course, since this is a fraction that we can reduce, 6 over 10 reduces to 3/5. Make that smaller, get it out of the way. Continuing, we get cosine is adjacent over hypotenuse. Adjacent to angle A is 8, and the hypotenuse is 10. That reduces to 4/5. And the tangent of A is opposite over adjacent, so that would be 6 over 8, and that's going to reduce to 3/4. Moving over to angle B. When we do angle B, obviously that will be our reference angle now. So the sine of B is going to be opposite over hypotenuse. The hypotenuse isn't changing, but the opposite is. Opposite of B is 8, and the hypotenuse is 10. That reduces to 4/5, just like we saw earlier. The cosine of B is adjacent over hypotenuse. So adjacent to B is 6, and the hypotenuse is 10, and that reduces to 3/5. And then the tangent of B is opposite over adjacent, which would be 8 over 6, which reduces to 4/3. Now, before we move on to the next problem here, I want to point out a couple of patterns that we see in this triangle. Since we're using two different reference angles, of course, we wouldn't expect the sine of angle A and the sine of angle B to be the same. But if we notice here, the sine of angle A is the same as the cosine of angle B. And similarly, the sine of angle B is the same as the cosine of angle A. And not quite as obvious, but a pretty important pattern here is that the tangent of A is the reciprocal of the tangent of B. And all three of these patterns you can notice by noticing that the opposite and adjacent angles switch when we switch reference angles. Okay, I'll move a little more quickly through this example. In this example here, we have another right triangle with a missing side, so we need to solve for that missing side first. To solve for side y, what we're going to have to do is use the Pythagorean theorem again. So we have y squared plus 6 squared equals 8 squared. And solving for y, we should get y equals 2 times the square root of 7. Now, the sine of angle x, we're going to use x again as our reference angle. So the sine of x is going to be opposite over hypotenuse. Opposite of x is 6, and the hypotenuse is 8. So we get 6/8 or 3/4. The cosine of x, we still have x as our reference angle, is adjacent over hypotenuse. So that's going to be 2 square root of 7 over 8. The 2 and the 8 cancel, and we're going to end up getting the square root of 7 over 4. And then the tangent of x is opposite over adjacent, which will be 6 over 2 square root of 7. Now we have two things we need to do here. The first thing we can do is we can reduce, But then also when we reduce, we notice that we have a square root in the denominator. So we'll make this a 3 and a 1, but we can't have that square root in the denominator. So to rationalize, we're going to multiply by the square root of 7 over the square root of 7, and we end up getting on top 3 square root of 7, and on the bottom just a plain old 7. Moving over to angle y as our reference angle, the cosine of y is adjacent over hypotenuse. So adjacent to y is 6, and the hypotenuse is 8. Tangent of y is opposite over adjacent. So opposite of y is 2 square root of 7 over adjacent, which would be 6. And then the sine of y is opposite over hypotenuse would be 2 square root of 7 over 8. Every one of these are fractions that can be reduced. We would reduce 6 over 8 to be 3/4. 2 square root of 7 over 6 reduces to be square root of 7 over 3. And 2 square root of 7 over 8 reduces to square root of 7 over 4. This last problem is unique because it doesn't have any side lengths here, so what we have to do is put our own side lengths in. We are restricted, of course, by the 60-degree angle here, so that this angle is going to tell us what kind of triangle this is. This is a 30, 60, 90 triangle. We saw this in the last concept. So what we're going to do is we're just going to use the most basic 30, 60, 90 triangle and go ahead and put the labels of 1, 2, and the square root of 3 in here, and use those side lengths to find our trig ratios. So we'll start now with the cosine of, the tangent of D. D is our reference angle. So the tangent of D is going to be opposite over adjacent. Opposite of D is 1, and adjacent is the square root of 3. Again, we have a square root in the denominator, so we need to rationalize here. So we're going to multiply by the square root of 3 over the square root of 3, and we end up with the square root of 3 over 3 as our rational answer. For the cosine of D, we have adjacent over hypotenuse. This one's a little bit simpler. Adjacent is the square root of 3, hypotenuse is 2. No rationalizing, no simplifying that have to be done, so all we have to do is move on to the next problem. The sine of D is going to be opposite over hypotenuse. This one is probably the simplest answer of all. Opposite of D is 1, and the hypotenuse is 2, so the sine of D is going to be 1/2. Now, this is useful to us because instead of D here, we could put a 30-degree angle, and we could just say the tangent of 30 equals the square root of 3, the cosine of 30 equals the square root of 3 over 2, and the sine of 30 equals 1/2. Now, if we move over to use our 60-degree angle as our reference angle, then we're going to have the cosine of E is adjacent over hypotenuse, so that's going to be 1/2. The sine of E is going to be opposite over hypotenuse, which will be the square root of 3 over 2. And the tangent of E is going to be opposite over adjacent, which is the square root of 3 over 1, or we could just write that as the square root of 3.